Good morning. Good morning, Coach Reza. My name is Temitope Ibrahim. So I want to present my assignment 3. So I will start by um, explaining my code and all that. So we are given 30 questions in assignment 3. So we are meant to analyze our data. We are given a data named test 03 and test 04. So I will start, for me to be able to analyze the code properly, I will start by importing Pandas as PD, which is used for data analysis. So first of all, the question one says we should read the test data given to us, which is in a CSV format, that we should read it into a variable called my df. So I did that by saying my df is equal to pd.read.csv. So I'm trying to read the data in the data set into like a data frame. So my number 2 question says I should get the data set info. So I'm using this function to get the memory size. Anytime we are using the data set.info, we are trying to get the data frame size, the size of the data frame. And we have two methods of getting this, which is approximate method and precise method. So approximate method, info function really will give us all information about the data frame. It will give information about column, about row, then about the memory size. So you can see that some of the columns here are integers, some are objects, as you can see here. So moving on. So we are asked to get the precise memory of the data set. So getting the precise memory of the data set is going to give us the memory of each column, as you can see here. Like this, the first one here, this dot info is just giving us approximate memory of all the elements in the data frame. But this precise method will give us memory of each column. So as you can see, index 132, ID 7,600, and so on and so forth. So those are the difference between the precise method and the approximate method. So we are calculating memory using approximate method here. You can see by each of the columns. So these are their memories. So moving on, we are also calculating memory using the precise method for each of the column. So we say we use this function md.memory underscore usage deep is equal to true, so that it will give us the precise memory of each element in the column. So number 4, we are asked to convert this continent into a categorical type. Formally, our continent column is an object. When you check this info here, when you go back here to check the info, you can see the continent is an object here. So we are asked in this number 4 to change it from object to category data. So this is the function to change this. My continent is equal to my continent as type. Then we put the category. That is what we are asked to change it to. Then we are now asked to check the memory when we change it back to category. So we can see that when we change it back to category, the memory reduced, because if a data is in a category type, it reduces the memory. It improves the memory by reducing it. Did you see that it's 1,710? But here you can see that it's more than 62,000. So that is what we are asked to do there. Then number 5, we are asked to display. We are asked to display categorical value sorted in data frame using code. So, continent, we have Africa, we have Asia. So instead of writing them as Africa, Antarctica, North America, we use code to denote them, like Africa is 2, Asia is 3. So we are using code to denote the continent in the data frame. So that is what we use this function for, my df_continent.cat.code. We are trying to code each of the continents by using numerical values. So and again, we are asked to check unique value of each column. That is what we do here. Then we want to check after doing that, after converting it to category, we are checking the memory. So the number 7, we are given another data set. We are asked to reload the same data set, which is a test 03, the data set we are using, but we are asked to reload it. So it was reloaded here again. Then we are asked to create a dummy variable for the continent. So that is what we did here. And this is our output after creating dummies variable for the continent. What they mean by that is like we are creating another column for each of the continents. And any continent that we are not calling for, we write, you can see the column for each continent. This is continent Antarctica, continent Asia, continent Australia, and so on and so forth. So anyone that we are not calling for, if it is Asia that we are calling to, it will write true. If it is other country, it will write false. So we are trying to create a different column for each of the continents here. And this is the printed result because we printed it as my DF underscore dummy. So he printed it out for us. So we have given a 2 data set in this particular question. So the test 04, we read it in, which has a school data set, school data set. Then in this data set, we have a subject called mathematics and physics. Then we have a result column in the data set. So for us to be able to, so we are asked to split this data set into training and testing. So for us to be able to split this data set into training and testing, we have to first of all import Skylearn model selection, import train test split. So you have to first of all import this from Python library. So by doing that, we have this function here. Then the data set is my school. We have to divide it to training 70% and test 30%. That's why you're saying test size is 0.3. Of course, the training will be 0.7, which is 70%. And we are using random states here just to tell our data that each time we run it, it should pick the same row and run it so that we get a consistent result instead of just picking randomly. So we are asked to save the training. We are asked to save the data, training data set. So we are also asked to store the test data set again. So that's what we are trying to say. We save the data set as CSV. So that's what we are trying. I mean, we are saving the train and the test data set as CSV. So that is what this function is meant to do for us. So moving on, we are asked to store the mathematics and physics into a variable called S, which is our feature variable. So this is our feature, our mathematics and physics. So our S is the feature variable. Then the Y, we are asked to save it in the result column, we are asked to save it in a Y variable, which is our label. Our Y is our label, our X is our feature. So moving on, we are using this logistic regression to find a pattern. We are using it to find a relationship between X and Y. So invariably, we are using the regression to find a relationship or a pattern between feature and label. So this is the result here. You can see it. So moving on, we are trying to store the value of of Y for the test. So these are the functions we use to split for the training and the testing. We split the data into test and train. Like I said earlier, train is 70%, while test is 30%. So these are the functions that we use to store them. So we want to see how it looks like. So we printed the test head and we printed the actual test head too. So we can see the results here. So moving on, we want to be able to predict the results for the test data. Then we now print the actual values here, the predicted value as well. So you can see the output, down here. So this is the actual values because we say print actual value. Then this is the predicted value down here. This is the predicted value down here. So we are asked to also calculate the accuracy the accuracy of the models that we are using. So we have accuracy for 90% accuracy here. For the logistic regression, we have 90% accuracy. Then moving on, we are asked to also use another model called decision tree. So we want to calculate accuracy of decision tree before. So this is the accuracy of the logistic regression. So we want to calculate the accuracy of the decision tree model as well. So we need to import skyline tree, import decision tree to be able to, from Python library, to be able to carry out this prediction properly. So we have our functions written here. Model fit S train, Y train, Y predict test is equal to model predict S test. So this is the function for the accuracy. At the end of the day, we got an accuracy of 0.96%, which is 96%. So we now want to compare both accuracy. The accuracy figure for logistic regression gives us 0.9, as we have seen up there. Then the accuracy for decision tree, accuracy for logistic regression gave us 0.9. Accuracy for decision tree gave us 0.96. So these are the two decisions. And the best one is a decision tree accuracy because it's higher than the logistic. So moving on, the number 17, we are asked to serialize the data set, which means we are trying to convert this data set into a special format. So for us to do that, we have to convert the train data set and the test data set, which is 17 and 30, into a special format. We want to convert the data set into a special format so that anytime we want to use it, we'll be able to pick them and use. So that is what this function is saying, train.pico. So we are converting it into a special pico format. So that's what we are doing there. Then the number 18, in the data set of this my school, we are asked to change the time column from text to a proper date. You know, on a normal day, the CSV, the date and time on the CSV file given to us is just a normal text type. So we are now asked to change them into proper date format and display them. So you can see, we now say print my school dot d types. So these are the types, just the normal data type. The ID is an integer. The math, physics, they are all integer. The result is object because that one is just pass and fail if you check the data set. So converting the data type of the date format to normal date time, this is our result. You can see 2022, 2010 December on the 14th, the 901, 9, yes. So this is the output. So we are now asked to extract our hour and year and extract them and create a special column for them. So this is this function, my school hour is equal to my school time dot dt dot hour. So we are trying to extract the hour and the year separately and put them in a new column. So that's why we want to now see how the thing looks like. So that's why we have to in the first 5 rows. So we can see that we have our hour separately, then we have our year separately in a column. This is our column. So that's how we come about that. Then again, we are asked to filter timestamp where our date is greater than January 1st, 2015. So any date that is greater than January on the 1st of January 2015, we are asked to filter them out. So this is the function to filter them out. So at the end of the day, this is the result we got for it. So you can see, if you check all these data, you see that all the data are greater than 1st of January 2015. So this is why you use this function. T is equal to PD timestamp 1125. So we are trying to filter data greater than 1st of January 2015. So that's that. So we also have to plot a graph. So we have to import this matplotlib so that we'll be able to plot our graph properly. So what did they ask us to do here? They're asking us to count the occurrence each year. So by doing that, we have to use this function to bring them out. Then the kind of bar chart the chart we are using is bar. So we have to indicate so that it will bring out. So this plot that shows how to bring out about the graph. So counting how many times each year appears. So that's what we have to do. And you can see the year. So that means 2009 appears less than 2.5. Then 2010 appear more than 17 times. So that is what that one is saying. So we are asked to, this number 22 question, we are asked to display duplicate rows for math and physics. And anywhere there is a duplicate value for math and we are asked to display them. But there's something unique about this question. We are asked to skip the first row. So that's why we are giving the function, we after writing the function, we say keep is equal to first. That is display all the duplicate rows for math and English, but skip the first row. So we're skipping the first row for us. So that's why we use this function keep first. So that means it should not display the first one. So moving on, we're also now asked to to display all the duplicate rows for both math and English again, but this time around we should display everything. So that's why we say keep first. That means display everything. Don't keep anything. Don't keep the first one. Don't keep the second row. Just keep is equal to first, which means display everything. So this is the result we got for all the duplicate value there without skipping any row or column. So moving on, we set the display option to show 500 columns. So this is how to set it by putting the option display does match the column then comma 500. That is, we are telling it to display option to show 500 column. So the number 26, we are trying to modify the display format for floating points number. So number 27, we are asked here to create a data frame. A data frame is like an Excel file or a table that has rows and column, a proper rows and column, just like an Excel file. So we are now asked to create a data frame with just any random number. So this is the function to do that. df underscore random is equal to pd.data frame mp.random rand init, that it should give us a random number from 0 to 101, then size 3, that's 3 rows, 4 columns. So we are giving the instruction that we want it in 3 rows, 4 columns. So we have 3 rows like this, 1, 2, 3, then 4 columns, 1, 2, 3, 4. So it's the instruction that we are giving it that is giving us back. So it's creating a data frame for us with 3 rows, 4 columns. And it's generating the random number from 0 to 101. So this is the result that is bringing you. So the next question says that, okay, this data frame that we have created here, convert the values to a float. So of course, you know a float is a decimal number. So it's converting them to decimal number here, 56.0, and all this one are showing being converted to a float type. Then again, we're trying to print the maximum value in each row here, the maximum value from this number 28. So we are trying to print the maximum value by writing this function. Okay, print data frame for us. So it's doing that. Then the last one, the last question, displaying the column names with the biggest number in each row. So that's what the question asks us to do. So we should display the column names with the biggest number in each row. So in each of the row here, so it's displaying the biggest number in them. So that is why it's giving us this output here. So that is the end of the code. Thank you for listening. I will stop my recording. I thank you so much. Bye.